Welcome to the session. Today we would be discussing interior of the earth. In the previous class we have talked about how landforms are formed. Now formation of landform was one of the things that was contributed by the crust or the outermost layer, as we had learnt in the previous class. In this class we would be talking about the structure or the interior of the earth, and this would help us in our further lectures on earthquake and volcanoes, the formation on intensity of earthquake and volcanoes. So let's start by understanding the basic classification for the interior of the earth. There have been numerous classifications for interior of the earth that have been given by various scientists and geologists. We would be covering that towards the end of the session. Let's first understand the broad classification. So if I have this as a section of the earth, I can divide it into three broad sections. That's the crust, mantle and core. Now I am trying to simplify it as easy as possible. So all these three layers I can divide again as upper and lower. So you have upper crust, upper mantle, lower mantle, and upper core or lower core, or I can say outer core or inner core, outer mantle or inner mantle as well. So these are the terminology that are interchangeably used. It can be either upper crust or outer crust, and inner crust or lower crust. So outer, so upper versus outer, and inner versus lower. That is interchangeably used throughout this lecture. Now this is a very fundamental structure of the interior of the earth. There are few things that govern this classification. First is the temperature. On an average, we say temperature increases by 32 degrees Celsius, by 1 degree Celsius for change of every 32 meters. Based on this, if I want to calculate for the first 100 kilometers, I can say the temperature changes 1 degree Celsius for every 32 kilometers. So 32 meters, so I can say it's 1 degree Celsius for 32 kilometers or 32 meters, or I can say 12 degrees Celsius for every kilometer. So that's for the first 100 kilometers when I move interior in the earth. For the next 300 kilometers, what happens is the rate of temperature decline decreases and it becomes 2 degrees Celsius for every kilometer. And finally, up to 500 kilometers or the core of the earth, I could say the interior around 3000 kilometers, I could say, would be 1 degree Celsius per kilometer. So this is the pattern of temperature decline in the interior of the earth. So one of the parameters that we consider is temperature. The next parameter that we consider is density. The third parameter is the effect of meteorites. And the fourth parameter that we consider is the earthquake waves. So all these broadly govern the pattern of the interior of the earth. Now some of the geologists have said rock type is also an important parameter that governs the classification for the interior of the earth. If I talk in terms of volume, I can say the outermost layer or the crust occupies just 1%. If I talk about mantle and core, I can say they are equal in thickness, but in terms of volume, mantle occupies around 84% of the volume core occupies around 15% of the volume. So this is in terms of volume that I am saying. But this core, despite having less volume, forms around 32% of the total mass. So the most important thing to understand here is the crust, where most of the activities takes place, has only 1% of the total volume of the earth. Now when I say 1% of the volume, I can say this crust is the basis for formation of all landforms that we have studied. So you can say, based on the plate tectonics theory, there are around 12 tectonic plates that form this crust, and these 12 tectonic plates, at the region where they meet, they either form earthquakes or volcanoes, or are a region for mountain building, which we have understood in the lecture on mountain building. So that is something that we have talked about crust. Now let's come on to mantle. Between crust and mantle, and between all these inner and outer layers, there are series of discontinuities. So 1, 2, 3, 4, 5. So there are 5 major discontinuities that exist in the interior of the earth. We would be understanding a trick to remember these 5 discontinuities and the order in which they come. So that's usually and commonly asked in the examination. Now the discontinuity between crust and mantle is important, and that is known as Moho discontinuity or Mohorovicic discontinuity. Now this discontinuity is important because if I say in a layman's language, no one has ever seen this discontinuity. This has never been seen or visualized by anyone, but it has been detected by sharp increase in the speed of the earthquake waves as they move down. So that discontinuity is a major factor that governs, or is a major region below which the speed of the earthquake waves increases at a much higher pace. And this is known as Mohorovicic discontinuity because of the name of the person who discovered it, who was Andrija Mohorovic. So that was something about crust. Now let's move on to mantle. When I talk about mantle, the upper mantle is a zone of less velocity waves of earthquake, now the crust is usually formed of either sial, that is the sialic rocks, or the basaltic rocks, but the upper mantle is formed of padolite, olivine, or kind of various igneous rocks, I could say. Then there is again a transition zone. The transition zone in mantle is important because this zone is the zone that governs the movement from less density to high density or more density, I could say. So this discontinuity that lies between upper and lower mantle kind of separates or is a marking line for the density. And finally you have the lower mantle. Now lower mantle is important because lower mantle is made up of iron and magnesium silicates. Beyond the mantle you have the core. Now core, if I talk about either outer core or inner core, both the cores are made up of iron, we denote it by Fe, and you have oxygen, sulfur in form of alloy for this core. Now very specific characteristics of the core of the earth. The outer core, remember, the outer core is liquid. In contrast to this, the innermost core or the innermost section of the earth is solid. Now, if I swipe back to the concepts of earthquake that we study, we have three types of waves, the P waves, S waves and the compressional waves. So when I say the outer core is liquid, that means S waves cannot propagate through this region, while inner core, that is solid, allows both P and S waves to propagate. The outer core, which is liquid, does not allow S waves. So what happens to the S waves? The S waves which are coming here finally convert into compressional waves, and these compressional waves we also call it K waves in case of earth interior. So S waves which cannot pass through the liquid or the outer core gets converted into K waves or the compressional waves. And finally you have the inner core, that is again solid, and it allows both P waves and S waves to pass through it. So this is something that we have tried to understand about the interior of the earth or the classification of the earth. Now let's move on. I would like this diagram to be here so we'll understand how the discontinuities are studied. So if I move on, you have this as a very good shortcut trick to remember the various discontinuities that exist. For those who are studying this for theoretical examinations or kind of examinations in which you have to write the answers, you need to remember this. But for those who are preparing it for a purpose of multiple choice questions, this is a very good trick that would help you learn the various discontinuities very well. So I can remember this as Kaho Mr. W.G. Lehmann. Now CO stands for Conard discontinuity, and that's the first discontinuity that I have marked here. So if I mark it as 1, this is 2, this is 3, this is 4 and this is 5. So one that exists between the outer crust and the inner crust is known as Conard, and this CO comes from here. Then you have Mr. that is M and R. So M we already learned that it's a discontinuity between crust and mantle, and it is significant because beyond it there is a significant change in the speed of the earthquake waves. So between crust and mantle you have the Mohorovicic discontinuity, or we also call it as Moho discontinuity. So M, and then you have R, that is Repetiti discontinuity that exists between the outer and the inner mantle. So 3, that stands for R. Then you have between the mantle and the core, we call it WG, that is the original name for this discontinuity, which is known as Weichart-Gutenburg discontinuity. Some people also simply call it as Gutenberg discontinuity. So you can also say it as Gutenberg discontinuity or Weichart-Gutenberg discontinuity. Both of them are correct, and that is the discontinuity between mantle and core. And finally between the outer core and the inner core exists the discontinuity which is known as the Lehmann's discontinuity. So these 5 are the primary discontinuities that we need to learn. Now there is one thing we just missed out in the previous section. So mantle and core. How do we understand the composition of mantle and core? I said this is composed of iron. The lower mantle is composed of iron and magnesium silicate. The core is composed of mainly iron with alloy that is formed by help of oxygen and sulfur. How do I come to know how these mantle and core are composed? Now there are various studies that have been done. To find out mantle, there are three primary ways that we usually apply. First is the heat flow, the magnetic studies, and the gravity studies. In the initial section when we started, we talked about temperature, density and type of rock as some of the major parameters. Besides that, to understand mantle, these three things have been considered very important. In contrast to this, when I talk about core and finding the composition of the core, there are few things that I need to know or few methods that by which I can do that. First is laboratory experiments on melting, understanding the alloy and its composition. So these are two things that we can do in laboratory. The things that are done in kind of field studies imply magnetodynamo field study. So that's magnetic dynamo field study. That's one of the things, and finally you have the inertia of the earth. So based on these things, we understand the composition of mantle and core, the various discontinuities that exist between crust, mantle and core, and the outer and the inner layers respectively. So we have marked this as 1, 2, 3, 4 and 5 respectively with the diagram. We have marked 1, 2, 3, 4 and 5, and this is the abbreviation or the mnemonic, I could say, that we can remember for the various discontinuities. Now we have gone through the process of interior of the earth, the sections of the interior of the earth, their composition, how they are formed. But besides this, there have been various classifications that have been propounded by different geologists. So let's just have a brief glance at those. So the first is the mechanical division, that was the first among all the classifications that was established, and this classification talked very simply about 4 basic sections of the earth. It talked about the crust as the lithosphere, which constitutes around 80 to 100 kilometers and is made up of plates coming from the same plate tectonic theory. Below that you have the layer of asthenosphere, which is liquid or plastic, I could say, above which these plates float. So that is asthenosphere, that's 100 to 200 kilometers. It's again a low velocity zone and less viscous. Then you have the mesosphere or the complete mantle, and finally the barosphere or the core of the earth. The next classification was given by Holmes. Holmes classified interior of the earth based on 2 things, that's Sial and Sima. Now under chemistry, if you learn the periodic table, Si stands for silica, and you have Al for aluminum, and finally Ma for magnesium. So it's said that the upper layer, which is crust, is made up of Sial, that is silica and aluminum, while the lower layers or the mantle is composed of Sial, which is silica and magnesium, and both of these are further subdivided as the outer and the upper and the lower layers. The next classification was propounded by Gracht. He said there are 4 layers, the outer silica and the inner silica. He talked about the respective thickness and the density, and then he said below that there is a layer of mixed metals and silicates, and finally the core or the lower mantle is made up of metallic nucleus. Daly, similar to the previous classification on mechanical division, classified just 3 basic terms, that's outer, intermediate and central. He mentioned the depth and the density. So both these classifications, the Van de Graaff classification and Daly's classification, focused on the density, and they said the density increases as we go towards the interior of the earth. Now whenever we go from mantle to core, there is an interesting phenomena that the density would increase, and that would be around 30%, but at the same time there would be decrease in the velocity of earthquake waves, and that decrease in the velocity of the earthquake waves would be again around 30%. And finally, there was Jeffrey's classification. Jeffrey classified based on the rock type. He said the outermost layer is sedimentary in nature. The second layer below the outermost layer is made of granite. Then you have third layer, which is diorite, which is a kind of intermediate intrusive igneous rocks which is formed by high pressure and temperature of the rocks above, and it's intrusive in nature. And finally, you have the fourth layer as the alkogite, and these we will understand in detail when we will be talking about the rocks and their types. So with this we cover the interior of the earth, the various classifications propounded by various geologists, the basis of the interior of the earth, and the major discontinuities that you need to know for various competitive examinations. You can subscribe to Examrace channel for any further